In this video, we'll calculate an enthalpy change for a chemical reaction process. The one that I've selected is that we're going to be looking at the combustion of butane gas. Because butane is a hydrocarbon, it does contain quite a bit of chemical potential energy. So when it reacts with oxygen, this energy can be given off in an exothermic process. The products of the reaction are going to be carbon dioxide and water, and because there's quite a bit of energy given off, we can record that here. Now in this problem, we're actually going to calculate the exact amount of energy given off by this reaction process. In order to do that, we need to have this value right here. Now this is telling us that we are looking at the change in enthalpy for combustion of butane. The value for this is 2,877.5 kilojoules per mole. So this is referring to, if we burn 1 mole of butane, how much energy is going to be given off. The negative sign here is actually telling us that this is an exothermic process where the energy content of the products is going to be lower than the energy content of the reactions. So the enthalpy change is going to be negative. Again, if we were to interpret an energy diagram, we can see that the energy content for butane would be at a higher point. The energy content of the products, the carbon dioxide and water, is at a lower level. So when we calculate delta H, it would actually work out to be a negative value. Again, this is letting us know that we're looking at an exothermic reaction process. This problem really boils down to doing some simple dimensional analysis. In order to do that, we are going to need to convert the mass of butane to be combusted from 0.13 grams to a number of moles. In order to do this, we'll need to know the molar mass of butane. So we've calculated the molar mass for butane. That works out to be 58.14 grams per mole. Again, this is calculated by using the subscripts from the chemical formula. Because carbon has 4 atoms present in a butane molecule, we're going to do 12.01, the mass of carbon, multiplied by 4 to get 48.04. The mass of hydrogen, 1.01, will be multiplied by 10 because there are 10 atoms of hydrogen present in a butane molecule. My first step will be to convert from grams of butane to moles of butane. We'll use this value, 2,877.5 kilojoules per mole. I did decide to leave out the negative sign in front of this value. That's really a preference thing. I know that this is an exothermic process, so I know that the energy I'm calculating is going to be energy given off. It may be the case that you'll be asked to report a negative value here. And again, a negative value just indicates that the energy is being given off by the reaction process. Completing the calculation, we're able to determine that there are 6.4 kilojoules of energy which are going to be released by this process. Again, I'm going to indicate that this is an exothermic process by saying that the kilojoules of energy are being released. Another way of doing this would be to report a value of negative 6.4 kilojoules, indicating that the overall energy of the products is going to be lower than where the reactant started.